So here we're going to talk about the if statements, and to do that you need to understand the relational operators. So hopefully you watched the previous video about the relational operators and how they work and the results they give back. On the screen here I have that same program that was in that video for the relational operators, but in this case I inserted the if statements to help us control the flow of the program. So the only thing I added was this if statement here that's looking at the result, that variable that we created in the program that's either going to be true or false based on the relationship operator. So now, what does an if statement do? Right? It's asking the question, if whatever's in parentheses is true, do the next line of code, else skip it. Right? So in this scenario, if result is true in this case, it will output this cout statement. It will do this statement. If this is false, it skips it and comes down to here and does this statement and then does this if statement. So we're controlling the flow by saying, okay, we only want to do this cout statement when result is true. Right? When it's false, we don't want to do anything. Right? So it only controls, the way we have it right now, this one cout statement. Alright, so let's take a quick look at the results there. Alright, compile here. There it is. Alright, and now you can see that the output is far less than what we were looking at before in the other video, and the only result you see is when it's a 1. When result is 1, meaning true. Okay, so if we were to look through this, right, we have the 5 and the 3 again for the x and the y. So is x greater than y? That is true. So result has the value true. So if result is true, output that statement. So that's the first one we see here. The next one, it jumps down to here saying is x less than y. That is not true. So result has the value false. So if result is false, it's telling it then to skip this cout statement. So this becomes false, it jumps down to here, the very next statement after the if. And then it's going to check is x greater than or equal to y. That is now true, so the if statement is going to be true. So we get the second output there. Alright, so we only have one more output to match. So let's see what happens here. X less than or equal to y. That is false. So this if statement is false. So again it skips and comes down to here. Is x equivalent to y? That is also false. So result has the value false. So the if statement is false. It skips the cout and comes down to this other result where it's asking or determining is x not equal to y. That is true. So result has the value of true. So in the if statement is true, then we get the third and final output of this grouping. Okay, so here we're determining using the relationship operator in an equation, putting the result into a variable, then using the variable inside the if statement. Typically, sometimes you might find this variable result referred to as a flag, because it's either true or false. It's indicating something. It's flagging something to us. So you might find that terminology used by me or others. Okay, so when we're referring to a flag, that's what we're talking about, the result of some kind of relational operator. Alright, so I'm going to press enter in our program here. It goes down again to the next grouping here, and this really hasn't changed. It's the same thing going on, except now instead of using the variable, I got rid of the result altogether here. The values of x and y I did not change. Right? I do not believe. Let's make sure of that. Right? Did not change it in this example. So we're still using the value of x has a 5. You can see, and the y is a 3. Right? And I can actually show you that. I'm not in debug mode, so I couldn't show you that. Sorry. So the results should be the same, and they look the same. There's 3 outputs, right? All with 1s. So you don't have to set it to a variable and then use the variable in the if statement. You can use the relationship operators like this in the if statement, and they work just the same. Because the if statement is looking as to whether this is true or false. Is x greater than y? That is true. Right? So we got the output. This is false, so we skip that cout statement. This is now true because x is greater than or equal to y, so we get the second output. This is false. so the if statement's false, skips the output. This is false also, so it skips that output. This is true, so it gives us the third one, the third output there. Alright, so you can use it with variables or without variables. This has less code and less variables. Alright, so maybe a little cleaner, right? But it's all up to you. If you feel more comfortable doing it the other way, that's fine. But these conditions, as we call them, right? This is what we refer to as the if statement condition. Right? What is its condition as to whether it's when it's true or false? Right? So that's another terminology you're going to hear. The book refers to it. You're going to hear other programmers talk about it in that sense. Right? That's the condition for when you want this if statement to be true, to do these statements that are part of the if statement. All right, so again, condition, a flag, right, appears the result variable. It's what we refer to as a flag, indicating something. Things to be careful about. Right? In C++, in general, all statements have semicolons at the end of them. Notice there are no semicolons on these if statements. They do not belong there. If you place them there, which I will do now, on every one of them, right, at least for the first grouping, right, and we rerun this program, and it's giving me compile errors. What did I do wrong here? A lot of warnings. Oh, because I got the old program running still. Doesn't like that. Alright, run that again. All depends on how you compile the program. Alright, so the only thing I changed here was those semicolons, and the result is completely different. And the reason is because the semicolon ends the if statement. So this if statement is not controlling this cout statement. This cout statement will always happen, even though it's indented. Right? The indenting means nothing. That's all about formatting, which I was going to talk about shortly. Right? The semicolon there ends the if statement, meaning this if statement has control over nothing really. Whether it's true or false, this cout statement will happen. Right? So that's another common programming error. Right? For beginners, because we all say that all statements have a semicolon at the end of it. An if statement does not. There's a select few statements that do not have semicolons at the end of them. Right, so the if statement is the first one. Right, the other common programming error, which I kind of mentioned in the relationship operator, is doing this. This will result in always being true. You can always do an assignment. So it's always going to give you a true. This is always going to be a true. Right, so two more common programming issues to worry about. All right. Again, now about the formatting, like I said, let me undo everything I just did. So we'll get rid of those semicolons. And it's not doing what I wanted to do, so we won't worry about it right now. What I wanted to show you, oh, it did clean it up. Okay. The next thing I wanted to talk about is using floating points. You see I'm using integers for the two variables here. You can use floating points, but because of the way computers process the floating point data and store it, you may get somewhat inaccurate results. So if statements and these relational operators work best with integers. The floatings can give you, if you need very precise determination, you may not get it. Right? The way the decimal portion of a double or a float value is stored, right, can give you some kind of crazy results that you're not expecting. Okay. So be aware of that as we're going along. Alright. So that's your if statements, and we're going to expand a little more on this. The way this is currently written, this if statement controls only the very next statement. If I was to place another cout statement here, it simply says hello. Alright, and we run this program. Close this one out and run that one. Hopefully I didn't break anything along the way. So now you're going to see that the control is maybe not what you expect. Alright, there's the hello. Alright, it's underneath the if statement. It's indented like the other statement, but it still printed it. Right? And in this case, x is greater than y. It is true. So you kind of look at it and you're just going to say, yeah, both those statements should be executed. Both should be outputted. Okay? So let's change it a little bit so that it's the other way around. X is the 3 and Y is the 5. Alright, so what results are you expecting to see here? Alright, let's see if you agree with what I have here. First statement output is the hello. Is X greater than Y? No, so that's false. So we did not get this statement. But we got this statement. Is X less than Y? That's true. So we got this statement. This cout statement is not part of the if statement. Right? The way the if statement is written, it only controls the very next statement only. And that's this cout statement. So this is the only thing it's controlling. To have it control more than one statement, we got to add in curly brackets around all the statements that we want to be part of the if statement. So the if statements start with the opening curly bracket and end with the closing curly bracket. So now both of these cout statements are dependent on whether this is true or false. Right, so it allows us to group multiple statements to be controlled. Same thing's going to happen if this is false. It jumps down and does this statement. Right, if this is true, it does this cout, then it does that cout in that order. Alright, so it's controlling whether it's going to do its statement or statements based on, and the grouping of how many statements is based on the curly brackets. So if it's true, do everything between the curly brackets. If it's false, jump down here to the next thing. Right, to the next statement after the closing curly bracket. So if we were to go ahead and compile and run this one, we should not see that cout statement of hello. And there's the results, and there is no hello there. Alright, so again, to control a group of statements, we put a curly brackets around those statements that we want the if statement to control. Now the indenting here has no play on how the code executes. It's more about the readability of the code. I can cram everything onto the left-hand margin and it will work the same. I can take out these indents if I want, leave it like that. Still going to work the same, nothing changes. The indentation makes no execution control or decisions on the code. Okay, it's all about readability. We want to be able to clearly see that these two statements are part of this if statement. We know that because they're indented. They're kind of a subclass to that if statement. Right? And the curly brackets also show us that they're grouped together. I like the curly brackets lined up like this because I can easily find the matches. Right? You may find people doing this type of thing. It works just fine. Again, no change in it. But to me, it's not as clear as to where the if starts and where the if ends compared to this. All right. So a couple programming or coding style tips there. All right.